In this video, I'll walk you through how I identified serious misconfigurations on my university's website. I want to be clear, no harmful data is revealed. Everything you see is fully censored. This is done responsibly and legally. So starting with the reconnaissance phase, the first thing I do is look for subdomains related to the main website. Subdomains are basically additional entry points of a website, and finding them helps increase the overall attack surface. Each one can run different services, different configurations, and different security controls. More subdomains means more surface. Next, I analyze what services the website is actually running. There are multiple tools for this, but one of the most common is Nmap. Nmap helps identify open ports, active services, server technologies, and exposed network services. This tells us what the system is running and where to focus testing. You can also use browser extensions like Wapalizer to quickly detect the technologies a site is built on. In my case, the website was running technologies like SQL and Laravel, and a few other components. After identifying the services, the next step is discovering hidden directories and files. These are paths that are not linked publicly, but still exist on the server. For this, I use a technique called directory fuzzing. It automates the process of testing thousands of possible paths automatically. I use a directory fuzzing tool with a word list to automate this entire process. For the word list, I am using SecLists. It is a standard collection used in real-world security testing. You can download it using this command. With the help of that, I was able to find some hidden directories. You can also use different directory word lists from SecLists, depending on what kind of content you are trying to discover. This time, I switched to another word list from SecLists, focused more on configuration and sensitive files. And this time, I was able to find some really serious information disclosures. One of the files I discovered was the env file. An env file is used to store application configuration and sensitive environment variables. This file exposed critical application details, like the application key, database connection details, and other internal settings. From here, it is technically possible to interact with the application backend, but I will not take this any further, because this testing is being done legally and responsibly. After that, I continued directory fuzzing on discovered paths. This technique helps uncover files inside other directories that are not meant to be accessed directly. Using this approach, I was able to find Laravel log files on the system. These log files can expose internal errors, application behavior, server structure, and sometimes even session-related information. Now, there is a known attack vector related to Laravel log files. If a user accesses a non-existent path on the server, Laravel generates an error. That error gets written inside the log file. In some misconfigured setups, these log files can be abused to inject malicious input, which may lead to remote code execution. So at this point, I wanted to continue testing this website further, but as you can see on the screen, the site is no longer responding normally. Instead, it's showing a bandwidth limit exceeded message. This usually means the server has reached its resource limit, and it can no longer handle incoming requests. In most cases, this happens due to poor hosting, limited infrastructure, or improper traffic management. Because of this, I can't continue testing right now, and instead of forcing requests or causing instability. Also, I haven't uploaded on this channel for around 13 days. This was mainly the reconnaissance. In the next part, I'll continue with full manual testing. So if you found this video useful and want to see how this continues, make sure to like the video and subscribe to the channel.